Hello everyone, I am Mr. S.M. Ganwat, working as Assistant Professor in Mechanical Department at Sharad Institute of Technology, College of Engineering, Yadrao, Ichalkaranji. Today, we are going to solve a problem of stress analysis of a rectangular plate with a circular hole by using ANSYS2021R1 software. Now, first we'll look at the problem. The problem statement is: in the plate with the hole under plane stress, find deformed shape of the hole and determine maximum stress distribution along AB. We are going to take thickness as 1 mm, modulus of elasticity, that is E, 210 GPa, Poisson's ratio 0.3, diameter of the circle 10 mm, and we are going to analyze the problem with assumption that the plane stress with thickness that is utilized. Now we are going to solve this problem with the software ANSYS 2021R1. Now we are going to proceed this problem. We are going to click on File, Clear and Start New, Do Not Read File, click on OK, then click on S. Now it's time to select the preference. Now we are going to select the preference. Click on Preferences. We are going to select the structural, as we are going to solve the structural problem. Click on OK. Then we'll proceed further with the next step, that is preprocessor. Click on preprocessor, click on element type, click on add the element. We are going to select the solid quadratic 4 node 182. Click on OK. Now as we are going to solve this problem with plane stress with thickness, click on option, change the element behavior K3 as plane stress to plane stress with thickness. Click on OK. Now close this window. Now we move further with the next step, that is selection of real constant. Click on real constant, click on add, click on add button. The element is basically selected, that is plane 182. Click on OK. Add thickness as 1 mm, click on OK. Now we are going to move further with the next step, that is the selection of material properties. Click on material properties, material models, structural, linear, elastic, isotropic. Ex is going to represent the modulus of elasticity. In the problem, that is given as 2.1 into 10 raised to 5, and we are going to take the Poisson's ratio as 0.3. Click on OK. Now close this window. Now we move further with the next step, that is of modeling. Click on modeling. Now we are supposed to create this particular rectangle first, which is of size 60 mm by 40 mm. Now click on create. We are going to create the area. Click on area, click on a rectangle by 2 corners. We are going to select the option by 2 corners. Then specify the x as 0, y as 0, width is basically 60 mm and height is 40 mm. Click on OK. This is the rectangle that we have created by using this particular area tab. Now click on again the area, as we have to create a circle at the center. Click on circle, click on solid circle. Then we are supposed to mention the x and y along with the radius. Now you are supposed to specify the center point of the circle. Now we are going to put the values for the same, as x is equal to 30, y is equal to 20, and the radius given for this problem is, that is the diameter is given as 10 mm. Therefore the radius will be 5 mm. click on OK. The solid circle is created exactly at the center of this plate. Now we are supposed to subtract the solid circle area from the rectangle area. Now click on the second option that is present over here, that is operate. Click on booleans. Now we have to subtract the circle area from the rectangle area. Now click on subtract areas, then you will get this particular window. Now we are going to put the first created area, that is of a rectangle, as we are going to subtract the area of circle from the rectangle. Now put 1 as the area of rectangle. Click on apply. Then again we have created the second area of circle, that is put 2 right over here. Click on OK. You will get the subtraction of the solid circle from the rectangle. Now the next step is the meshing part. Now we'll move further with the meshing part. Click on meshing tab, click on mesh attribute, then pick on picked area, select the particular area, then click on OK. It will ask you the area attribute. As we have got the same material properties throughout the section, we are going to put the same values over here. Then material number will be 1, the element type will be plain 182, real constant set number 1, then click on OK. Now we'll move further with the size control. Click on size control, manual size, click on areas, then I am going to select the second option, that is picked area. Click on picked area, select this particular area, then click on apply. Then you are supposed to identify the element edge length. I am going to put this value as 2 over here. Click on OK. Now we'll move further with the next step, that is the mesh. Now click on mesh areas, click on areas, click on the second option that is given, that is free. Select the particular area that you want to mesh, then click on OK. The mesh pattern will be generated for the given region. Then you can visualize this particular, if you want to visualize the thickness, then click on plot control, style, size and shape. Then you are supposed to make the display of elements on by clicking on this particular tab. I am going to on the display of elements, then click on OK. Then you can visualize the thickness by clicking on isometric view. It is visible that the thickness allocated to this particular plate is 1 mm. Then again I will take the front view for the sake of convenience. Now suppose I want to remesh, or I want to modify the mesh which is basically present near the circle. Then we are going to utilize the mesh tool. Click on mesh tool, then in mesh tool we have got the option that is refine. The mesh that is basically selected is area, the shape is called free, and refine at level you are supposed to check the option as element. Click on refine. Then after clicking on the refine, you will get this particular refine mesh at element. Then what you are supposed to do, you are supposed to click on the circle tab, then pick appropriate center of the circle and drag it on the outward direction like this, and release this button. Then click on apply. Then you can modify the level of refinement so that we can get the better results at the circle section. Then level of refinement will keep at 2. Then I am going to click on OK. You will find the refinement of the elements is basically accomplished at the circle area. This is done so as to get the proper results at this particular sudden change in cross section, and will get the better results. Now it's time to go for the boundary conditions. Then after completing the meshing activity, we'll move further with the next step, that is of loads. Now I'm going to click on the load button. Then we have got the option that is define load. Then I'm going to click on define load. In that second tab is apply. Click on structural displacement. We are going to restrict the displacement from this particular line and for this line. Then click on line. I'm going to pick this particular line and this line. Click on apply. Then I want to restrict all degrees of freedom for this particular area. Now I am going to select this all degrees of freedom. The displacement value will be 0. I am going to click on OK. Then I have restricted these two segments for as boundary conditions. Now again I will follow the same path, that is loads, define load, apply, structural. Now I am going to put the pressure on the remaining edges. Click on pressure on lines. Then I am going to select this first line. Click on apply. The value of load pressure will be minus 500. Click on OK. It will show you the direction of the pressure applied on the edge or line. Now similarly the same process I am going to follow, that is load, define load, apply, structural, pressure on line. Now I am going to select the second line for application of boundary conditions. Click on apply. Again I am going to take the same value as 500 Newton, 500. Then click on OK. The second boundary condition is applied on the second line. This is the formulation of the given problem. Means we have generated the geometry, we have carried out the meshing activity, then boundary conditions are basically incorporated in this particular problem. Now all the problems with the given parameters are set. Now we'll move further with the next part, that is of solution. We are going to click on solution. There is a tab called solve. Then we are going to click on current load step. You will get the message as begin solution for current load step. Click on OK. You will get the message as solution is done. Then close this particular window. Now we have solved the problem for the given condition. I am going to click on the isometric view. Now we will proceed further with the next part, that is of general post processor, where we are going to view the results of the problem. Now click on read result, first set, last set. Now we are going to plot the results. Click on plot results, counter plot, nodal solution, degrees of freedom, x component. Click on OK. You will get the displacement, or we call it as the nodal solution for the given problem, and you can visualize the variation of displacement from a particular value to a maximum value. You can capture this particular image for your documentation purpose. Similarly, it is possible to get the element solution. Click on element solution, then click on the stress, then click on von Mises stresses. Click on OK. You will get the distribution right over the area. This is the elemental solution for the given problem. Now you can list the results that are obtained. Just I am going to click on nodal solution, degrees of freedom, x component. Click on OK. You will get the nodal solution for the nodes that are generated, and similarly the maximum value, the displacement value, will be present at node number 42, and the value will be 0.57769 into 10 raised to minus 1. So total number of nodes generated for the given problem are 1088. Similarly, you can go for the element solution. von Mises stresses, click on OK. Similarly, you will get the results for the elemental stresses for the given problem, and you can again save this particular file for your documentation work. Then we can animate this particular problem from plot controls, animate, deform shape, deform plus undeform. Click on OK. You will get both the shapes in the animated view. This is the deformation that is occurred for a plate with circular hole. You can close this animation by clicking on the close tab. Then you can list the results from list result tab. You can plot the results from plot result tab. These options are basically utilized in general post processor to view the results. And also there is a facility called style color reverse video. This will help you to get out your documentation for printing. Counter plot, nodal solution, X component. You can plot these results for documentation work, and in this way it is possible to solve the problem. Means the problem is basically stress analysis of rectangular plate with circular hole, and we have determined the stresses that are basically developed for a circular plate, rectangular plate with circular hole with these given conditions. You can again go in style, colors, reverse video, and you can obtain the results for the different situations. This is all about the problem that we have discussed, that is stress analysis of rectangular plate with circular hole. And you can again vary the holes that are present in the plate with different positions. Means suppose I want to put these holes at the corners of the plate, you can modify your geometry and go for the results in the same way. See, the problem is basically defined as per the data. If the data is given in such a way that we can go for utilizing the different problems, and it is possible to solve the same problem with ANSYS2021R1 software. Then you can save this particular file as save as job name db. Then click on save as. You can select a particular directory to save this particular file. You are supposed to assign a particular name. And after giving the name and location, you can click on OK. You can particularly save this particular file as per the location. And this is all about the problem that we have solved, that is stress analysis of rectangular plate with circular hole. Thank you.